Hello guys, let's have a look at another question in the A-level curriculum for today. Let's read the question. A beta particle, a beta minus particle in fact specifically, from a radioactive source is traveling in vacuum with a kinetic energy of 460 electron volt. Electron volt is a smaller unit of measure for energy, whose standard unit is joule. The particle enters a uniform electric field at a right angle and then follows the path as shown. Here the direction or the path of the uniform electric field is in the plane of the paper. The direction of electric field is in the plane of the paper as shown. Draw an arrow to show the direction of electric field. Now, let's start writing all the information given in the question. The kinetic energy of the particle is 460 electron volt. We know that electron volt is not the SI unit of measure of energy, which would be joule. So the conversion is 1 joule is equal to, or let me write it this way. 1 electron volt of energy is equal to 1.6 into 10 to the power of minus 19 joule. So to convert this into joule, just multiply this value 460 by 1.6 into 10 to the power of minus 19. This value then becomes expressed in terms of the SI unit, which is joule. Now they're asking us to show the direction of electric field. A beta minus, as indicated, is a negatively charged particle. We know that negatively charged particles are deflected such that they always go in the opposite direction of the electric field. Electric field is generally taken to be directive from positive to negative. And since negative charged particles are attracted towards the positive, they always get deflected in the opposite direction of the electric field. And since the deflection seems to be upwards, it is safe for us to assume that the direction of electric field is down. So this is the direction of electric field indicated by the electric field lines going downwards. Moving on to the next part, calculate the speed of the beta particle before it enters the electric field. So kinetic energy is what we have here. How do we find out speed from kinetic energy? Kinetic energy by definition is half times m times v squared. So here the kinetic energy in SI units is 460 into 1.6 into 10 to the power of minus 19. This is equal to half. A beta particle by composition is nothing but an electron and an antineutrino. An antineutrino is of zero mass and hence irrelevant to our question. The mass of an electron can be taken from the data booklet as 9.11 into 10 to the power of minus 31 kilogram into v square, which is the unknown we need to find here. Substituting, simplifying, and rearranging, we get the value of v to be approximately 1.3 into 10 to the power of 7 meter per second. Let's move on to the last part of the question. Other beta particles from the same radioactive source travel outside the electric field along the same path that is shown in the figure 7.1. State and briefly explain, whether those beta particles will all follow the same path inside the electric field. So to answer our question, no, particles will not follow the same path, as beta particles or the motion of beta particles is random. And since the motion of beta particles is random, the angle and the direction in which they are deflected, or the deflections that occur are also not uniformly directed in a particular direction. So deflections are also random. So this acts as evidence to further strengthen our answer that no, the beta particles will not all follow the same path inside an electric field. Thank you.